start the new topic inverse trigonometric functions basics for board syllabus. Okay, let us consider the function f of x is equal to sin x. F of x equal to sin x. So already we did know very well the actual domain and range of the function sin x. This is the function that is sin x, actual domain and range. Actual domain is real number set and range is closed interval of -1 comma +1. Now the graph of f of x that is equal to y that is equal to sin x. Let us consider the graph of y equal to sin x. This is y is equal to sin x graph. Let us consider from minus pi by 2 to plus pi by 2 means this much of curve. In this area for different values of x, different y values are there in this area, just like that. So what I am telling that in closed interval of minus pi by 2 plus pi by 2 in closed interval of minus pi by 2 to plus pi by 2, f of x that is equal to sin x is 1 function and onto function means what? In closed interval of minus pi by 2 plus pi by 2, sin x is bijective function. So what I okay, keep it up. Next, actually sin x domain capital R real number set means here observe that f of x is equal to sin x. What is f of 0? Means sin 0. Sin 0 equal to 0. Similarly, I will show one example. Sin pi is what? Sin pi. Sin pi is what? 0. F of pi equal to sin pi 0. Similarly, okay, f of 2 pi is also means sin 2 pi is also that is equal to 0, and so on. Similarly, infinite values are there which are mapping with the 0. What I am telling that entire this domain, it is the sine function. Okay, of course it is the range. Range is a closed interval of -1 comma 1. This is the range. So 0, suppose pi, 2 pi, like that infinite numbers are mapped with only 0. Of course it is belongs to closed interval of -1 comma 1. So therefore entire in its domain, that is real number set, f of x is equal to sin x is not one function, because different elements are mapped with only one element. So it is not one function. Therefore sin x is not bijective function. So already I said in the functions only the bijective functions will have its inverse. Therefore, whenever it is not bijective function, therefore sin x do not have its inverse in its domain, its actual domain. It is actual domain, that is capital R. Therefore, sin x do not have its inverse. Therefore, in this area, sin x is not bijective function, and that to be sin x doesn't possessing its inverse. Okay, it is one concept. So, to avoid this inconvenient, we are restricting, we are reducing, we are concise the domain so that it is a bijective function. What is that restricted area or bijective area? This one, closed interval of minus pi by 2 plus pi by 2. Of course, in this area means minus pi by 2 to plus pi by 2 means this area. For example, the curve will be like that. It is minus pi by 2, it is minus pi by 2, this one is plus pi by 2. So in this area, this curve will be like that. Here, this is bijective function. Not only in this area, it is bijective function, but also observe the graph from pi by 2 plus pi by 2 to 3 pi by 2, this area also means, so first area, closed interval of minus pi by 2 plus pi by 2 comma, next closed interval of pi by 2 to 3 pi by 2, 3 pi by 2, 3 pi by 2, later 3 pi by 2 to 5 pi by 2, 3 pi by 2 to 5 pi by 2, so positive side and so on like that. Next negative side, you come here. This is minus pi by 2 to minus 3 pi by 2 in this area. In this area means in closed interval of minus 3 pi by 2 to minus pi by 2 and so on, negative side just like that. Means in this area minus 2 pi to minus 3 pi by 2. Here also it is bijective function. So this is sin x is bijective in these areas. Means these are called restricted areas or bijective areas. Actually, this is actual domain. This domain is different. I am telling that in real number set means throughout on real number, sin x is not bijective. Sin x is bijective in, suppose closed interval of minus pi by 2 to plus pi by 2. In this area, sin x is bijective. 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 Therefore, in this area, sin x will have its inverse. In this area also, sin x is sin x having its inverse. In this area also, sin x will have its inverse. In this area, just like that. So, how many areas are there? Infinite areas are there. Out of which this area minus pi by 2 comma plus pi by 2 minus closed interval of minus pi by 2 comma plus pi by 2. It is called principal value branch. This area is called principal value branch. So therefore, I am telling that f from capital R to closed interval of minus 1 comma 1, f of x is defined as sin x is not bijective. Therefore, for all x belongs to, x means domain, x belongs to capital R, sin x will not have its inverse there, but the restricted area means f from closed interval of minus pi by 2 to plus pi by 2 to closed interval of range should not be changed in any case. In this area, I mean f of x that is equal to sin x is bijective function. Actually, in the functions, if f from capital A to capital B is a function, means this is called domain, it is called codomain or range. Then its inverse is denoted by f inverse and defined as B to capital A. Means what? Codomain or range will become the domain of inverse function, and domain will become range or codomain of inverse function. In the same sense, f inverse means this range becomes domain. Next, its domain becomes range, closed interval of minus pi by 2 to plus pi by 2 f inverse of x. Actually, inverse function is denoted by sin inverse x or arc sine function. So therefore, in this area, this is the restricted area or principal branch. In this branch, sin x will have inverse. It's a inverse. Thus, it is defined as f inverse from closed interval of minus 1 to 1 to closed interval of minus pi by 2 to plus pi by 2, and f inverse x equal to its notation sin inverse x or arc sine. This is the notation for sin inverse function of sine. Okay, this is the definition of sin x. Once again I wish to repeat once again this concept. Actual domain is capital R. In this total area, infinite area, it is not bijective function because I have given one reason. So therefore, in this domain, in this actual domain, sin x do not have its inverse. That's why to get rid of this inconvenient, we are restricting the domain like that. So what are the restricted areas? Some infinite areas are there, namely closed interval of minus pi by 2, closed interval of pi by 2 to 3 pi by 2. It can be seen in the graph. That's why read sin x graph. Okay. In this area, sin x is bijective. In this area also sin x is bijective, and so on. In this area also sin x bijective. So therefore, how many areas are there so that sin x is bijective? There are infinitely many areas are there out of actual domain. That's why out of these, which one is the principal branch area? Closed interval of minus pi by 2 means principal means main branch, closed interval of minus pi by 2 to plus pi by 2. That's what I wrote here completely. So once again, f from capital R, it is actual domain. No confusion. Actual domain. This is restricted domain. Restricted domain or bijective domain as invertible domain. It is called invertible domain. Invertible means in that area it has inverse like that. Okay. Once again, f from capital R to closed interval of minus 1 comma 1. This is actual domain. This is actual domain. No confusion. This is actual domain. This one is restricted domain. Restricted domain. So that it is bijective. So in this area, of course, range is same. Sin x is not bijective. Therefore, it has no inverse function. But in this area, this is restricted domain. In this area, sin x is bijective. So only the bijective functions will have their inverses. Therefore, its inverse defined as or denoted by f inverse from closed interval of this range become domain, this domain become range, just like that, just like according to this basic. Okay, closed interval of minus 1 comma 1 to closed interval of minus pi by 2 to plus pi by 2. It's the inverse notation, f inverse. It's the inverse denoted by sine inverse x or arc A or C. Sometimes we are writing A or C sine, SINE. So both are same. This is the notation and a definition, some explanation with the help of a sin x graph, sine inverse x. Okay. Next, you come here. Next, if sine inverse x is equal to theta, some most important points regarding sine inverse x. Okay, if sine inverse of x is equal to theta, then that by implies x is equal to sine theta, subject to the condition x. X means what? Domain of sine inverse. X means domain of sine inverse x, sine inverse domain. X means domain. So is equal to theta, that by implies x equal to sine theta. For all x belongs to, what is its domain? Closed interval of minus 1 comma 1. What I am telling that this is the function, this is the function, this is the domain, this is the range, this is the range. Function, which function? Sine inverse x. What is its domain? Closed interval of minus 1 comma 1. What is its range? Closed interval of minus pi by 2 to plus pi by 2. And sine inverse of x equal to theta, that by implies x equal to sine theta. Means wherever we are having this equation, immediately we can write like that, or vice versa. If x equal to sine theta, then we can write sine inverse of x equal to theta. Sine inverse of x equal to theta. 1 minute. Here x belongs to closed interval of minus 1 comma 1. At the same time, theta must be belongs to closed interval of minus pi by 2 to plus pi by 2. For example, sine inverse of 1 by 2, that is equal to theta. That is equal to theta. Means it can be written as half is equal to sine theta. Before using this formula, verify. You must verify that first whether this x belongs to closed interval of minus 1 comma plus 1 or not. Here 1 by 2 strictly belongs to closed interval of minus 1 comma 1. That's why it is correct. Another example. For example, sine inverse of 3 by 2, that is equal to theta. 1 minute. So habitually you can write, sir, you said now here, if sine inverse x equal to theta, then x equal to sine theta. That's why sine inverse of x equal to sine theta. We can write like that, sir. No, don't write like that. Before writing 3 by 2 is equal to sine theta, you must verify here x is equal to 3 by 2. First question yourself, is it belongs to closed interval of minus 1 comma 1 or not? Here 3 by 2 means it is 1.5, but 1.5 is not belongs to closed interval of minus 1 comma 1. Therefore we should not write like that. So therefore before using this formula, we must verify whether x is belongs to closed interval of minus 1 comma 1 or not. That's all. Moreover, already I said if sine inverse x is equal to theta, that by implies x equal to sine theta, whereas x must belongs to closed interval of minus 1 comma 1 and theta must be belongs to closed interval of minus pi by 2 comma pi by 2. So actually in the functions if f from a to b is a bijective function, then its inverse b to a is also bijective. So what I am telling that in this area means minus pi by 2 plus pi by 2 closed interval of minus 1 comma 1 to closed interval of minus pi by 2 to plus pi by 2 sine inverse x is also bijective function. So therefore f from closed interval of minus pi by 2 to plus pi by 2 to closed interval of minus 1 to 1, f of x defined as sin x is bijective, and similarly f inverse minus 1 to plus 1 to closed interval of minus pi by 2 to plus pi by 2, f inverse of x is defined as sin inverse x. Sin inverse x is also bijective function. Next, moreover, here sin inverse of sin theta we can write simply theta. It is for all theta belongs to closed interval of minus pi by 2 plus pi by 2. It is one formula, and another formula, sin of sin inverse of x, that is equal to x for all x belongs to closed interval of minus 1 comma 1. If theta is not in this area, so then we should not write as theta, means sin inverse of sin theta is equal to theta. We should not write that. What I am telling that if theta is in this area, then only we can apply this formula, otherwise it is not true. Similarly, if x is belongs to in this area, then only sin of sin inverse x is equal to x, otherwise it is not equal to x. Okay, I will explain to some beautiful examples. For example, sin inverse of sin pi. We should not write like that. We should not say pi. Means what? Sin inverse of sin pi not equal to pi, because pi is not belongs to closed interval of minus pi by 2 comma plus pi by 2. It is for one failure case. So another, sin inverse of sin pi by 3. Here, before saying pi by 3, my question is pi by 3 belongs to closed interval of minus 90 comma plus 90? Yes, it is correct. Pi by 3 means 60 degrees. So 60 degrees belongs to closed interval of minus 90 plus 90 degrees. Therefore, we can write simply it is pi by 3. It is success case, it is a failure case. So, for this example over, now let us consider the example for second statement. Here, second one, sin inverse x is equal to x. So x must be belongs to closed interval of minus 1 comma 1. One example, sin inverse of 3 by 2 or 4 by 3. So it should not be equal to 3 by 2 because 3 by 2 means what? It is 1.5. 1.5, it is beyond the limit of closed interval of minus 1 comma 1. Next example, sin inverse of root 3 by 2, that is equal to. Here, before using this formula, first you observe whether x is belongs to closed interval of minus 1 comma 1 or not. Here root 3 by 2 means 1.7 divided by 2. So approximate equal to 0.85 like that. Okay, it is belongs to closed interval of minus 1 comma plus 1. So we can write directly it is root 3 by 2. So this is the best example. So if f is bisective, then f inverse is also bisective. It is one point, and second point, sine inverse of sine theta equal to theta. Theta must be in this area, otherwise we should not write like that. We should not apply like that. Next formula, sine of sine inverse x equal to x. X must be in this area, closer interval of minus 1 comma plus 1. Otherwise we should not write like that. So for these two statements, I have given some beautiful examples. Once again, another most important point, sine inverse of x. Actually in algebra of real numbers, x inverse is equal to 1 divided by x. Means it is reciprocal of x, but it is not in the same sense. Sine inverse means it is just arc sine function, but it is not at all equals to sin x whole inverse, or sin x whole inverse means 1 by sin x. 1 by sin x is what? Cosecant x. So cosecant x is different, sin inverse of x is different. Similarly, sin inverse of x whole square is not equal to sin power minus 2 of x, just like that. Okay, understand. Next point, if sin inverse of x1 is equal to sin inverse of x2, we can write it as x1. That implies x1 is equal to x2, because sin inverse is also bisective. If it is bisective, then only it is possible to say x1 is equal to x2. Otherwise we cannot say like that. Okay, I will show another example. For example, find the value of sin inverse of 0. Sin inverse of 0. Here sin 0 is what? Sin 0 degrees equal to 0. Means it is in the form of sin theta. Where is that? Sin theta is equal to x. It is just like sin theta is equal to x. Here theta is equal to 0, x is 0. Then we can write sin inverse of 0. Sin inverse of 0 means this 0 is equal to sin inverse of this 0. We can write like that. Similarly, for example, sin 60 degrees equal to root 3 by 2. From the principal table, sin 60 degrees equal to root 3 by 2. So we can write it as 60 degrees. We must habituate to read like that. 60 degrees equal to, it is sin inverse of root 3 by 2. When it is possible, this theta must be belongs to closed interval of minus pi by 2 comma plus pi by 2, and this value must be belongs to closed interval of minus 1 comma plus 1. If both are possible, then only we can write like that. Otherwise it is not possible to say like that. This is all about the sin inverse function. Let us consider the function f of x is equal to cos x. Actually, this is the function actual domain and range function cos x. Actual domain real number set, range is same, closed interval of minus 1 comma 1. It is about cos x. Okay. So I am telling that in entire the domain capital R, cos x is not bisective. In capital R, cos x is not bisective. How? For example, f of pi by 2 cos 90 0, cos 3 pi by 2 is also 0. Means what? It is pi by 2, next 3 pi by 2. So both are mapped with the element 0 in the codomain closed interval of -1 comma 1 or range. This is the domain. That is what real number set capital R. So therefore clearly f is not 1 function in x belongs to capital R. Therefore f inverse therefore first we will talk about bijective. Therefore f is not bijective, means cos x is not bijective in capital R. So therefore f inverse does not exist for all x belongs to capital R. That's why we restrict the area, or we are choosing some sub intervals so that cos x is a bijective function. Here cos x actually 0 to pi. Let us consider 0 to pi. In this area, means in this area, the curve will be like that. The curve will be like that. So this is x-axis. So from here to here, this function is 1 function and on to function, because this is -1. So this one is +1 on the y-axis. So therefore codomain is equal to range. Okay. For every different values of x, we are having different values for y, just like that. Thus it is onto function. So therefore I am telling that cos x is onto function in closed interval of 0 to pi by 2, and as well as it is 1 function. Therefore in closed interval of 0 comma pi, cos x is bijective. So we can obtain, or we can arise another doubt, sir, in only closed interval of 0 comma pi is it bijective? There is no any other interval for bijectivity. You can ask me like that. No, 0 to pi in this area it is bijective. Later pi to 2 pi in this area also it is bijective. Later 2 pi to 3 pi in this area it is also bijective. So infinite areas are there. Similarly negative side here it is what minus pi by 2. It is what 1 pi by 2 to minus pi. It is minus pi. So minus pi to 0 it is bijective. So in negative side also totally so many infinite intervals are there, so that cos x is bijective, out of which this closed interval of 0 comma pi is a principal value branch. This is the main branch of cos x bijective. So what I am telling that f from capital R to closed interval of -1 comma 1, it is what actual domain. It is what range. Comma defined as f of x that is equal to cos x, that is equal to cos x is not bijective, Therefore f inverse does not exist in this area, but f from the principal branch 0 comma pi, of course the range is same, -1 to +1, range is same, because f is onto function. So comma f of x is equal to cos x is bijective function. Therefore f inverse exists. Remember, f from in this area f of x equal to cos x is bijective. Similarly f inverse exists, and f inverse is also bijective. Make a note. Okay, next f inverse is defined as range becomes domain, domain becomes range, closure interval of 0 to pi, comma, f inverse of x is equal to cos inverse x, or we can write it as arc, arc, cosine. This is the definition of in cos inverse x. Okay. Here, likewise in sin x, one formula is there. What is that? Cos inverse x is equal to x, whereas x is what? Domain of cos inverse. Domain of cos inverse means closed interval of -1 comma 1, and cos inverse of cos theta is equal to theta for all theta belongs to closed interval of 0 comma pi. If theta in this area, then only cos inverse of cos theta is equal to theta, otherwise it is not equal to theta. Similarly, in this interval, closed interval of -1 comma 1, x belongs to closed interval of -1 comma 1, then only cos of cos inverse x equal to x. And if cos inverse of x is equal to something theta, then y implies x equal to cos theta, whereas x belongs to closed interval of -1 comma 1, and theta should be belongs to closed interval of 0 comma pi, closed interval of 0 comma pi. Then only this equation or statement is true, otherwise it is not true. Okay, some examples. Let us consider some examples. Here cos inverse of, let us take 1 by 2. 1 minute. Cos inverse of x equal to x. Okay, we can write x. X means what? 1 by 2. I am asking one question. This x, is it belongs to closed interval of -1 comma 1? Yes. Otherwise, it is not possible to say 1 by 2. Next, failure case. Cos inverse of 4 by 3. So that is not equal to 4 by 3 because it is not belongs to closed interval of -1 comma 1. 4 by 3 means it is beyond 1. It is greater than 1. It is greater than 1. Therefore, it is not belongs to closed interval of -1 comma 1. Similarly, let us consider this statement. Cos inverse of once again, cos inverse of cos theta is equal to theta. 1 minute. Theta should be belongs to closed interval of 0 comma pi. For example, failure case. Cos inverse of cos 2 pi. Cos inverse of cos 2 pi. Perhaps, or even if it is in the form of cos inverse of cos theta instead of theta. Sir, instead of theta 2 pi is there, you just write 2 pi. No, it is wrong because 2 pi is not belongs to closed interval of 0 comma pi. So this is next success case. Cos inverse of for example 180 degrees. Let us take 3 pi by 4. 3 pi by 4 means 45, 3 is 135. Okay, that is equal to same 3 pi by 4 because it is belongs to closed interval of 0 to 180 degrees means pi. So this is for one failure case and one success case. Okay, next cos inverse. Similarly, like in sine graph or sine inverse, cos inverse, it is not in the sense of cos inverse x whole inverse, just like that. Cos inverse or 1 by cos. 1 by cos means secant x. Cos inverse x means that it is just arc cosine. These are the examples. Similarly, cos inverse of x1 is equal to cos inverse of x2. That implies x1 equal to x2 because in this area cos x is bijective. So therefore, F inverse is also bijective. Then only it is possible to express cos inverse of x1 equal to cos inverse of x2. That implies x1 is equal to x2. If cos is not bijective in the given area, then it is not possible to write the statement like that. Okay, this is all about cos inverse x. Over.